In practice, it's not feasible to measure an entire population, so we take samples from the population and use the samples to estimate population values. This process is called statistical inference. The sample mean is called a point estimate of the population mean. We're going to be studying statistical inference for the rest of the class. One way to make inferences is to use confidence intervals, and that's what we'll be talking about today. A second way to make inferences is to use hypothesis tests, which will be introduced in Lesson 4. As a simplifying assumption, I'm going to start off assuming we know sigma, the population standard deviation, because this lets us use the normal distribution. A second video will cover problems with unknown sigma. Confidence intervals are found using some level of confidence. The 90%, 95%, and 99% levels are commonly used, but you can actually use any level you want to, such as the 82% level. Anytime you use a sample and find a confidence interval for the population mean, there's some chance your conclusion may be wrong. In other words, sometimes the population mean will not actually be between the two confidence limits. Over the long run, a 95% confidence interval will be correct 95% of the time. But for any given confidence interval, you're not sure if it's correct or wrong. Each problem will tell you what level of confidence to use, but in this class, if a problem does not specify a level of confidence, my default policy is to use the 95% level. The 95% level of confidence uses the z-value that finds the middle 95% of the area under the standard normal distribution. The area in the tails, 0.05 in this case, is called alpha, and half of alpha, 0.025 in this case, is the area in each tail. In the next lesson, we'll start using one-sided as well as two-sided confidence intervals. Here is a typical example of a question that asks you to find a confidence interval. If a sample of 153 items has a sample mean of 100 and the population standard deviation equals 10, find the 95% confidence interval for the population mean. The next slide uses R as a smart calculator to find the confidence interval. In Lesson 4, we're going to learn how to use some R functions that can directly find the confidence intervals. Look at each line of this code and try to think about the logic of what I did. In line 1, the object named n is defined to equal 153, and this is the sample size. In line 2, the object x bar is defined to equal 100. This is the sample mean. In line 3, sigma is defined to equal 10, and this is the population standard deviation. In line 4, the object SE is calculated by dividing sigma by the square root of n. This value is called the standard error of the mean, and it's the standard deviation of the sampling distribution of the sample means. In line 5, the object named alpha is defined as equaling 0.05. This is the area in the two tails when the 95% level of confidence is used. In line 6, the object named z is defined using the qnorm function. So inside the parenthesis, alpha equals 0.05, so 1 minus alpha over 2 is the same thing as 1 minus 0.025, or the value inside the parentheses equals 0.975. So you combine this with qnorm and you put 0.975 in the parentheses, and this is going to create the z-value that puts 0.025 of the area in the upper tail. In line 7, the object named ME is defined as equaling z times SE. This is the plus-minus value we add to and subtract from the sample mean. It's called the margin of error. In line 8, the object named ANS is defined as equaling the sample mean plus and minus the margin of error. The C function combines the negative and positive margin of error values. In line 9, I rounded the answer to 2 decimal points. Our conclusion is that we're 95% confident that the population mean is greater than 98.42 and less than 101.58. Thanks for watching. Confidence intervals are one of the primary ways to perform statistical inference, and we're going to be using some form of confidence intervals for the rest of the class.